Okay, hello class. I'm going to attempt to create an online video of our lesson. Being that we've had all this crazy weather and such, I hope all of you are staying safe. Please be careful if you're out on the roads. I actually came in today for our morning class before they cancel classes, and on my way home got into an accident. So definitely be careful if you're out on the roads. I highly recommend just stay off of them if you can, and just stay close to your emails. I will email you any updates regarding our class, but as for now, we're just going to work via online videos as of right now while classes are canceled. So we are currently headed into Chapter 2, Section 2.1 is where we're going to begin. So I want to start out by talking about the standard form of a linear equation. So if you look to the left of my screen over here where my mouse is, you'll see that I have written the standard form of a linear equation as ax plus b equals 0. So when you're talking about the standard form of an equation, it's basically when you take whatever equation you've been given and you set it equal to 0. And that's all that it is. Okay, and it allows us to solve for a specific variable. Okay, there's different types of equations that we can look at. We can look at an identity equation, we can call it a conditional equation, or we can call it a contradiction. Now, when you're learning the descriptions, I don't want you to sit there and try to memorize them, but instead think about what these words mean in regular vocabulary, in English vocabulary. When we talk about the identity of something, the identity is what you see inside of the mirror, right? I apologize if you hear the squeaking noise in the background. My dog is running around playing with his toy, so I deeply apologize for that. But all right, an identity equation is it's going to be true for all real numbers. So just like I was saying, you look in the mirror, you look at yourself, and you get your image back. You see exactly what is in the mirror of what you are, right? Well, it's the same idea in mathematics. When you get to the last statement where there's equal, the left-hand side equals the right-hand side. If they're equal, then that's an identity, and it lets you know that no matter what value you plug in, it's always going to be true. Now, conditional, think conditional is if this happens, then maybe this happens. So if I win the lottery, then I'm going to be rich. It's a conditional. Sometimes it can happen. If I don't win the lottery, then I won't be rich, okay? But is that always the case? No, I could not win the lottery, but then I could still be rich because I came up with a great invention or something. So it works sometimes, but not all the time. Well, in mathematics, that means it's going to be true for some real numbers. There's only certain values that will work, but there are also some values that won't work. And if you contradict, well, you're just wrong, right? If you contradict yourself, then you're not making any sense. Well, in mathematics, it's just saying that our equation, our final solution, it's going to be false for all real numbers. So if I gave you 0 equals 3, well, does 0 equal 3? No, that doesn't even make sense. So that would be a contradiction. So we want to look at some examples here. You'll see the problem: determine whether the equation is an identity, a conditional, or a contradiction. Okay, so I'm going to write out this equation. We have x squared minus 8x plus 6 is equal to x minus 4 all squared minus 10. All right. Now, we're going to go ahead and simplify this equation. X minus 4 all squared is just x minus 4 written 2 times. And you guys already know how to solve this part right here. You're going to do the process of FOILing. So first is x times x. Outer is x times negative 4. Inner is negative 4 times x. And last is negative 4 times negative 4, which is a positive 16. I'm going to bring down the minus 10. And the other side's already solved for me, so I don't really have to do anything. There's no simplification that can be done. Okay? I'm going to go ahead and combine my like terms here and here. So this would be x squared minus 8x plus 6 equals x squared minus 4x is minus 8x plus 16 minus 10 is plus 6. So here is the final solution. There's no simplification that can be done. So at this point, I want to identify, was this an identity, a conditional, or a contradiction? Well, I have the same exact thing on the left and the same on the right. Therefore, it is true for all real numbers, and this is an identity. All right? So you kind of get an idea of what we're talking about. Let's look at another example. X plus 6 times x minus 8 equals x squared minus 2 times the x plus 8. I recommend you to pause the video and try to solve it on your own. That way you can kind of make sure that you know how to go along with this. So on this part, you're going to FOIL. That's going to be plus 6x minus 8x minus 48 equals x squared. Notice that you have the negative 2, which needs to be distributed to both terms. Remember that negative sign is getting distributed as well. Don't forget about that common mistake. And then you're going to simplify x squared minus 2x minus 48 equals x squared minus 2x minus 16. All right, so now we're looking at this and we're saying, okay, hold on. So far, it's not looking equal to each other, okay? At this point, before we go and say, okay, wait, these don't equal each other, we don't really know. We just have two different equations. They may equal each other, they may not. So let's go ahead and get our x's on one side and get our numbers on the other and see if anything crosses out. So I'm going to put my x's on the left and I'm going to put my numbers on the right. So the x squared is going to stay, the 2x is going to stay. I'm going to bring this x squared over, that's a minus x squared. I'm also going to bring the minus 2x over, so that makes it a plus 2x. I'm going to bring down the negative 16, and I'm moving the negative 48 over to the other side, and that makes it positive. All right? Now, if you notice what happens here, x squared and minus x squared cancel out. 2x and minus 2x cancel out. That leaves me with 0. And 48 minus 16 is 32. Now, there's the end solution. 0 equals 32. Now, my question to you is that a true statement? No, that's not true. That does not equal one another. Therefore, it can't be true for any real numbers, and it is a contradiction. All right, we're going to look at our next example. This time I threw in some fractions. So we have 2 over x plus 6 over x equals 24. Now your book talks about solving this using LCDs, a least common denominator. I am 100% fine with you doing that method, although I think that's a little more difficult. However, in this case, because we already have a common denominator, it actually makes it easy for us to solve this. We can solve it straight across. So 2 plus 6 is just 8, and then over x equals 24. And then if you want to isolate x by itself, let's get rid of our fraction first. And that's my philosophy through this entire class. Whenever you see a fraction, multiply out its denominator. Well, if you do that to one side, you obviously got to do that to the other. These cancel out, and that just leaves you with 8 equals 24x. And then in order to isolate x, you're going to divide by 24. And we all know that we're able to simplify that. 8 divided by 8 is 1. 24 divided by 8 is 3. X equals 1/3. Now notice this time we have a value for x. X equals a particular number. That means this is a conditional equation. So yes, it's going to work as long as x is 1/3. But if it's any other number, it's not going to work. So it works sometimes, but not all the time. You kind of get an idea of what we're talking about here. So any equation can be identified as an identity, conditional, or contradiction. Now our next concept that we go into is solving equations. And the goal is to isolate x or whatever variable you are looking for by itself. And I said any variable because sometimes you won't be looking for x. Maybe you'll look for y. Maybe you'll look for b. I don't know. Look at the directions, okay? But whether you have numbers, letters, or a mixture of both, remember, your goal is always to isolate the variable that you are looking for on one side and put everything else on the other. That's always the goal. Okay, so in this example, we actually have fractions. X over 3 plus 3x over 4 equals 2. All right, now in order to get rid of these fractions, I want to go ahead and multiply out my denominators, okay? Now in order to do that, I'm going to take each term and multiply it out by its denominator. All right? That cancels the first term out and leaves me with x plus 3 times 3 is 9x over 4, and 2 times 3 is 6. Okay? Notice how now one of the fractions that I had went away. Your book talks about doing a least common denominator, okay? But I choose not to do that because I think this is so much easier, less to keep track of. What's my next fraction? Well, I got this 4 in the denominator, so now I'm going to multiply each term by 4 in order to get rid of that fraction. That leaves me with 4x plus 4 divided by 4. These are just going to cancel out, leave me with 9x equals 6 times 4 is 24. 9 plus 4 is 13x equals 24. And in order to isolate x, divide the 13 over, and you now have a solution. You have now solved the equation for x. If it simplifies, great. If not, leave it as is. Now, I always recommend you to check your work. For the sake of this video and for it not being too long, I'm not going to do that. However, you want to be sure you check it for WebAssign because there are times when that solution may not work, okay? And all you do is you plug this value, 24 over 13, for every single x you see. And once you solve the left-hand side, you should get the value 2, so that 2 equals 2. If it does, awesome, you did it right. If not, well then recheck it, okay? All right, let's look at another example. 3z minus 4, divided by 4 minus z over 10 equals 5. Same idea. If you want to make least common denominators, I'm fine. Go ahead. But I personally like to multiply out my denominators. Makes my life a lot easier to do that. So I'm going to multiply every term by the first denominator I see. They cancel out. And that leaves me with 3z minus 4z over 10. And 5 times 4 is 20. Now, the next fraction that I have is that 10. So I'm going to take each term, multiply that denominator out. Okay, 10 times 3z is just 30z. 10 and the 10 cancel out, leaving me with 4z. And 20 times 10 is just 200. 30 minus 4 is 26z. Equals 200, and z equals 200 divided by 26. And now we could obviously reduce that. I don't have my calculator on hand, but let's see. 200 divided by 2 would be 100. 26 divided by 2 would be 13, and I don't think that's going to reduce anymore. That should be our final solution right there. Okay? All right, we're nearing the end. Solving the equation for b. All right, now notice I've given you actually a special formula. This is the area of a trapezoid, okay? And in this problem, I have told you to solve for b, okay? Again, the idea is the same. Isolate b on one side, get everything else on the other. I don't care that you have all letters. It doesn't matter. Get b by itself, get everything else onto the other side. Treat it like it were numbers, okay? Now, when you put in your solution into WebAssign, be sure to pay attention to the capital and lowercase letters. Looking at this, what's the very first thing I can do? Well, all of this is multiplying together. 1/2 is multiplying times the a plus b, which is multiplying times h. So one by one, I'm going to move stuff over. So first, I'm going to get rid of 1/2. In order to do that, I either need to divide by 1/2, or we know that we can multiply by 2 over 1, the reciprocal, which means I need to do that on the other side. These cancel out, and that leaves me with 2a equals a plus b times h. Now, can I move the a or the b or anything? No, because the h is multiplying. I can't separate this addition yet because we got something multiplying it. So how do we get rid of the multiplication? Well, yeah, we do the division. So we're going to divide this side by h, and we're going to divide this side by h. So that leaves me with 2a divided by h equals little a plus b. Now, how do I get b by itself? Well, now I can go ahead and move a over. Well, a is adding to b, so now I got to subtract it. So I have 2a over h minus little a equals b. Notice the way that I wrote this. Make sure you write this correctly when you type this into WebAssign, okay? All right, and one last example, very similar. We have the interest rate formula. P plus PRT. Okay, and we want to solve for R. Okay, in order to do that, I'm going to first move this P over. I don't need it over here. Okay, the big P, little r, and little t are all multiplying together, so I can just divide out what I don't need, which is the PT. If I do it to one side, I got to do it to the other, and that leaves me with this solution. All right, and there you are. Now you're complete, and you have solved for R. Okay. You'll notice that your homework omit problems for 2.1 are numbers 14 through 20. Please work on those. Feel free to email me if you have questions, and make sure you write down any question numbers you need us to go over while we are in class. All right? Again, stay warm and have a great day.